Hello all, welcome to another session of ST Skills. Today we are doing a mock interview, and today we have Satyam as a mock interviewer and Kaustubh as a candidate, and they are going to chat about Pastebin. So with this, handing it over to you, these folks.
Um, all right, Kaustubh. So let's design Pastebin. Do you know what Pastebin is?
Yeah, I mean, I do have a rough idea, but yeah, I mean,
Okay,
it'd be
please
great if
tell
you could
me.
explain. Uh, yeah, I mean, Pastebin is where people, put up a text essentially, where and should that text should be accessible by a unique URL. Um,
Okay.
and that should have some set expiry, is what I believe, right?
Yes.
Yeah.
Uh, so I mean, if you can say, then what would be the usage of Pastebin? I mean, how do we use it?
Well,
What is its merit?
I think it is for. Let's say you have a large amount of text that you want to you don't want to share it over the network, and you just want instead of putting it in a USB or something, you just want it I think it makes sharing easier, is what I
Great.
believe. Yeah.
All right, then let's proceed with
So,
this.
yes. All right. So do you have a brief sort of overview to give me, or the requirements that you're expecting in this system?
Uh, I would suggest you start with the requirements,
Okay.
and I'll add up the things.
Okay. All right. So okay, let's start with let's start with the requirements gathering, and let's start with the functional
Mm-hmm.
requirements.
Mm-hmm.
And okay, so functional requirements, as we said, user should be upload or just paste the data. Uh,
Yes. Let's say just paste the data,
yeah, should be
not uploading a file or anything.
yeah, paste the content or data, and then how do we are we only thinking about text here? Can it be like an
Yes.
image? Okay.
No, let's keep it until text.
Okay, paste the data, to our service. And, service should generate service to generate a unique URL to access that, right? Access the paste or whatever the data, let's call it.
Yes.
Uh, and and data is only text. Okay, and so
Mhm.
okay, we have generated the URL. The next thing to that would be, what is the expiry, or is there going to be an expiration date or time on the URL?
Yes. Yes. That expiration time
Should
would
that
be
be
provided by the user.
okay? So it's like configurable parameter, right?
Yes.
Okay,
User can or
configurable.
cannot provide the expiration time.
Okay, and there should be a default. It should, if it does, if the user doesn't specify, the default expiry should be what, like a year, or probably more than that.
Mm, uh,
Let's begin with a year.
Whatever you think is good.
Okay. Okay, let's say 5 years. I mean, or yeah, I mean, we'll have to make a storage consideration accordingly. So, okay,
Yes, I mean, I'm leaving this number to you. So
okay,
whatever default expiration date you want to set, you can set it.
okay, okay. And should the user have a capability to choose uh, a custom URL? Like, can he choose an alias
Yes,
of his choice? Okay,
yes.
okay. Uh, that's good. Okay, so basically, user comes into the service, puts the data, service generates a URL. Uh, and data is only text, configurable expiry time. That should be pretty much it, right? That should sum up the requirements, right? The functional requirements at least.
Yes, the functional requirements are done.
Okay. All right. So in non-functional requirements now, system has to be highly available.
Yes.
That's the default.
Why is that?
Because we do not want our service to be down. So it goes both ways, right? So user is putting up. Oh, and I think we've missed a basic requirement. Just to state explicitly that user should be able to paste the data, but should also be able to access that data. So
Yes.
whenever I put that URL, it should be redirected to this service, and so that's why we need it to be accessible. So
Yes.
yeah, I think that's fine. I think highly available, so that covers it. We want that to be reliable as well. What that means is, any data that I have uploaded should not uploaded or pasted should not be lost, at least during that expiry period, custom expiry period, or default, whichever is greater. Right?
Yes.
Yeah, or it should always maximize to 5 years. It shouldn't. I mean, of course, the configuration. We should have a validation check where configuration expiry time cannot exceed 5 years. So should be reliable. There's one more. What else can we do? We should have a minimum latency.
Yes.
This is when accessing the URL. What else can be? Highly availability, and then we should have our system should scale on its own. It should have a scalable system. We should build it scalable so that if the user load increases, adding more servers should just auto scale. So the system should be able to auto scale, or like this can help us even during peak hours. We can scale it, and during like non-peak hours we can scale it down, something like that. So
yes.
Okay, and then a good to have will be like a maintainability, I think, or maintainability as in we should have some mechanism of doing a maintenance sort of a system. So it should be designed in a such a way that there should be minimum maintenance. I'm referring to consistent hashing, so that if more servers are added, removed, there should be minimum hassle on the system.
All right.
And I think final one that we can consider, it's like maybe an analytics kind of a data use case that we can say that we want that to.
Okay, that would be extended requirements analytics.
Okay, so let's just let's not think about it for now.
Yes.
Okay, I think these should be good requirements to start with, right?
Correct.
Okay.
This is all that I wanted.
Okay. Okay, so we have this, and so let's estimate let's estimate what the traffic is going to be, and based on that we can make a decision if it is our system is going to be read heavy or write heavy.
What do you think? Will it be read heavy or write heavy?
Well, it looks like it will be a read heavy system, right? Or yeah, because once you put a system there, like put your data there, you'll need you'll need the data to be accessible more often than you. So it is more likely that you will access your data more often than you will put the data there. So I think it would be a read heavy system, right?
Yes, it will be a read heavy system. Fine.
Right. Yeah, and do you want me to run these estimations or numbers?
Yes, until and unless you run the estimations, there will be some issues, or we'll have to anyways do it in the end, right?
Yeah. Okay. So let's do traffic, like this is the traffic estimation. Okay, so basically we're trying to understand what is like the QPS here, queries per second. Now we know that in a month we have 2.5 million seconds. I'm just trying to understand what's the fair number to reach at. How many requests do you think our system would receive per month or per day? Is
What is
2.5
your guess?
maybe like 100 million requests or so? Is that a fair number?
100 million requests per month.
Yeah, is that low or?
I think we can make it to somewhere around 30 million or 60 million.
Okay.
Because that would be 100 million would be too much, I think.
Okay. I mean, I usually base my my estimations based on the basic assumption or basic equation that 1 month is 2.5 million seconds. So, okay, and we want 30 million, 30 million requests.
30 million requests for what precisely?
This is to, oh yeah, we need to have 30 million requests, like the read request.
Okay, 30 million read requests, fine.
So we'll have to see both, right?
What would be the write requests then?
If we say, if we assume that our equation is 5 to 1, where this is read and this is write, read and write. So that would mean that if we have 30 million requests for read, we'll have 6 million requests per month for the write.
Okay, but let's say we have like 30 million requests per month for write, and
okay,
then we can draw the conclusion for read requests.
Yeah, it should be 1.5 billion, right? Okay. So this is clearly we will need data
150 million won't be 1.5 billion, right?
150 million. Yeah. 100 million.
What is this?
I hear someone else also. So are you saying something?
I was saying, like, if you have 30 million requests per month for write requests, then would it be 1.5 billion read requests per month? I mean, is that calculation correct?
I think it's wrong. I think 150 million it would be.
Yes, correct.
I think because I think 1,000 million is 1 billion, right? I was thinking.
Yes.
Okay. So that would give us somewhere like this 150 million requests per second would be how much, like in a month we have some ballpark figure. Should be something like 50 to 60, 55 requests per second. Is that fair to say for read? And 11 requests per second for write. I mean, I the way I came up with this is, in 150 we have 86,400 seconds in a month. So we just have
6,400 seconds in a month.
No, that's in a day. Sorry, that's
sure?
in a day. That's in a day.
Okay.
So the calculation will go like 86, or let's just say 1,000, or 100,000 seconds. It'll probably be easier in
A day.
a day, one day. And we have 30 days to look for. So 30 into this 100,000 into 3, 5. Okay. And divide that by so what are we, sorry, I just lost track of 30 million. So 30 days. So these are number of seconds, and we're calculating it for a month, right?
Now we are not calculating it for a month.
So these are the second. No, we are calculating it for per second. Okay. So basically,
Yes.
if 100,000 in a second. Okay. So these are the seconds, and okay. So basically, 30 million. 30
You have
million
already got
requests.
2.5 million seconds in a month, and you already have 30 million requests per month. So why don't you just divide the right requests by the total number of seconds present in a month?
Yeah.
Won't that give us
Yeah.
the approximate QPS?
Yeah. Should. 10⁶. That
Anyways,
10⁶ divided by this number, right?
anyways, we have come up with the 55 requests per
Yeah.
second feed
Yes.
and 11 requests per second for write. So
Yeah,
let's
okay.
proceed.
Yeah. Okay. All right. So basically, we have we've arrived at this ballpark figure, which basically what this suggests to us is that of course read requests are going to be much higher than write requests, and we have to evaluate our storage estimation or storage data that we're going to store, and the way we are going to store all of that needs to be based on this. Okay.
Yes.
And then let's move on to the database that we are going to use. Basically the storage considerations that we're going to. So basically, we broadly speaking, we have we have two options. Like we can evaluate both. Either we can go with SQL databases or NoSQL databases.
So are we doing storage considerations like database, or are we checking for estimations here?
Okay, I mean, we can do that first, and we can go to the
because you are suggesting that we can go for SQL or NoSQL, so that is mainly selecting the database, right?
Yeah.
Okay, then let's proceed with selecting the database.
Okay. I mean, and then the maximum data that we can put a cap on any data that the user can put in. Like it cannot be an infinite amount of data that the user will put it in our system, right? So we'll have to have a cap of something, and let's put a max cap of 10 MB. Is that fair to say? Because we already only have a text, and 10 MB will be, I think, more than enough per user.
And that is more than enough.
Yeah.
Way beyond enough, I can say.
Yeah. Okay. All right. So the database now. I mean, broadly speaking, we just need in our design, we just need two kind of. We're interested in only two types of data, right? First is the data that actually, like the data that the user has uploaded, and second is the user database that we will need to maintain, right? So those are the two things. First would be user data, and second would be the like I don't know, content data. So those are the only two things that we need to be interested in. And
what will these two data contain? I mean, what will they have?
Yeah, I mean, user data would be fairly straightforward, right? It will have like a user ID. Then it might have its login credentials. Like, let's just have a simplistic. Is it fair to assume that we'll have our user authentication taken care of? It should be.
Yes, I mean anybody would be logging in using
Yeah.
user ID and password. So fine.
But this service itself wouldn't deal with all the authentication stuff, right?
Yes, let's keep that aside for now, because
Okay.
as of now we are focusing on Pastebin, not on the authentication system.
Okay. So content data, this system would, not this table, database table will have the original text, or we can just say text, and this will have URL that the text can be accessed through.
Okay.
It might also have a user ID, the user that has created this, or this can also, this can also be null, meaning a guest can also put it there. We don't force user to log in and create a user ID.
Okay.
So, yeah, that's pretty much. And then yeah, I think we'll also need an expiry date. That this is either configurable or we'll default it to our default value of 5 years.
So we will be using the exact expiry date, correct?
Yes.
Okay.
Yeah, I think before that we'll have to see how much storage that we're going to need, right? So we have 10 MB, that's max capacity, that max request, and how many? So we'll need two assumptions here: number of users, and we have the max cap. And do you have any figure for number of users, like unique users?
Number of users.
Or we can go with we go with this number also, right? Because we already have these are the 11, like we have 11 requests coming up. We don't care about number of users. We just care about incoming requests, right? That's right. So like every
Yes.
incoming request, like we have say 11 requests per second, and 10, everyone can put maximum of 10 MB. So we'll have to provision at least for those. So 10 MB into 11, this will be.
But it's not required that everybody would be putting in 10 MB of data. That would be too much.
Right.
Not
Maybe
everybody
we can.
would be wasting that many. That amount of data.
So should we just have some assumption on the average data, average amount of data that the user will put in? Any user will put in, like a
Yes,
general
you
user.
can.
Okay. So let's just say then, we have maybe 5 MB, half of it, or even lesser.
We can keep like 20 or 30 KB, because that too will have like 20-30 lines of lines present in it. So fine.
Yeah. Okay. So this is like 220 KB of data every second. So and we will, okay, so this is a max cap, that's fine. So 220 KB per second is what our system is processing for writing, and 220 KB, and this is let's multiply it by 100,000 10 to 5. I'm just trying to see how much we need into. So the 10 to 5 is for a day into 30. This is for the entire month into how many months in a year, in 5 years, like 60.
Okay, so what would be the total data then?
10 to 5 is 180 or 1800.
180 into 220.
180 or 8.
Not just
it is going to be 10 to 2, and this is 10 to 5. So 5 and 2 is 7. That is 10 raised to 7.
Okay, you can assume anything here.
Okay.
Anything that is near to 18 into 22.
Okay.
Let's say it is 4. It becomes 400.
Okay. 400. This will be what, 4 GB, I think, because 10 raised to 7. 400 into 10 raised to 7, right? So 10 raised to 7. That is, yeah, that's 4M. 7 plus 2 is 9. That is, I think, 4 GB, right? This will be 4 GB, because 10 GB is 10 raised to 9. So 7 plus 2 is 9. I think it's 4 GB.
Okay.
So 4 GB of data that we will need. That's pretty low, right? Okay, that's pretty low for but this is per user, right? This is per user. We are going to provision 4 GB. No, not this. No, this was the entire right thing. Okay, I think estimations are probably lower on a lower side, but that's okay. I think we can deal with this for now. Okay, so
let's move on to HLD.
Yeah, sure. And should we briefly discuss about SQL versus NoSQL, or do you want?
We can do that.
Okay. I mean,
so you have just told about or we just discussed about the tables that we would have. So which database
I think
would you
NoSQL
say?
will be better, because we do not really need any joins. We do not need atomicity to be there.
We can also use a SQL, right?
Yeah,
Without
SQL
joins,
will do.
without foreign keys, without anything.
Yeah, SQL would do the job just fine, but this might give us more flexibility with NoSQL. Like in terms of schema,
Why?
we can the schema. We could alter the schema later in a NoSQL databases as against SQL. We have a strict requirement in SQL. So let's say we add a new field in user data. Something. Maybe I don't know,
Let's say
some
we
like
only
data
have
birth.
these many fields.
Oh, well, SQL will do just fine. If we just index on user, SQL will also do the job for us.
Okay.
Yeah. Okay. So let's move on to the high level design. Now here let's start. On a high level, we have a user, the client on one side. We have the service on the other side, and there is an interaction between them. And let's say this is the client, and since we are going to deal with a scalable system, let's just put a load balancer in front to balance the load. And there are multiple levels where we can put load balancers, so we can deal with it later. So now this is the client, this is a load balancer, and we can say we have an application server here. Let's just name them so that okay, so this is an app server. And there's another, and the important aspect is, of course, the storing of the data. Now, storing in terms of storage, we are going to need database server. But again, in order for us to make a minimum latency and faster fetch rate, we're going to need some cache servers also going forward. But we can begin with we can say we can have an object.
Are we discussing HLD or the complete design system for this right now?
Well, yeah. How to, like, I thought we are discussing the design, right? I mean, the detail. Do you want just the block diagrams first, and then we can dive into each of them? Or?
Yes, that would be good.
Okay. So let's just say the database. One of the aspects I probably did not mention earlier about database choice, the reason I was planning to go with a SQL, NoSQL database, was that we can segregate object storage versus a metadata, because we are going to need this. If we just have single storage, and that will be difficult to act. It will be a bottleneck database. Again, and we can, if we use NoSQL databases, we can use even content, CDNs also, like content delivery networks, to make the latency minimum. So that's also one of the sides of that we should consider. But on a high
All
level,
right.
yeah, and then we can put a load balancer even here in between these two, so that the traffic is evenly distributed among servers.
Mm-hmm.
And this is the client, right? Okay, and this is the app server. Okay, and the storage server.
What
Now
happens
database.
when a write occurs?
So, okay, let's just consider the first requirement, should be able to tell. Okay, so first the client sends a request to the,
Mhm.
to the app server, which is handled by, there could be another component in between, which could handle this, we can call it a gateway, kind of, which would terminate the request here, and which is like a gateway, which as the name suggests, it's a gateway between external systems and internal systems. So sort of, it can take it could act as a reverse proxy, etc. But we can
I
have
think
that.
load balancer can also work as reverse proxy.
Okay, uh, yeah, but okay, well, that can work as well. Okay, all right. So basically, the client sends a request to load balancer. Load balancer maps it to the correct app server where the request needs to be handled to. App server would would ask what database, like, again, this load balancer will balance the load, and
Mhm.
now we are putting the data to the database, we are updating the tables, and
Mhm.
this would be saved in the database. Load balancer will decide what database to go to, and what database server to go to. There are multiple, like, again, there are, for the app server, for database, there are going to be multiple instances running to make sure
Mhm.
the higher availability. So this is like, on a high level, this is what we are going to do. But like,
Okay.
again, yeah, database is very like abstract concept here. I think we need to, because I'm pretty sure after after our user load increases, this database is going to, like, one database server or only multiple database servers could lead to a bottleneck.
Yes, correct.
Yeah, so I
All
think
right. So the HLD is
yeah.
clear. So let's dive down.
Okay. Okay. So I was what I'm thinking is, in our service, whenever our service receives a request, we
Mhm.
map it to the database, and because
Mhm.
see, there are two types of requests that we are going to receive. First is, of course, the write, and the other one is fetching, the read requests.
Yes.
Now, if this is like a very simple setup. Let's just assume we only have one app server, we only have one database instance
Mhm.
running. This is quickly going to turn into a bottleneck. Even the write
Mhm.
requests can bog down the read requests. So we
Mhm.
we should segregate our read and write requests and handle them separately. That's the first thing we can do. And of course, the database, like I said, it's very abstract. We just have one box here, but I think we need to segregate it into, like, a metadata database and an object storage, something like Amazon S3, or there are a lot of a lot of these objects, blob storages in the market. So we can use something like that.
All right.
Okay, so let me.
So in object storage, you are storing the content as a file
Yeah,
in object
right.
storage, correct?
Yes, yes.
Fine.
That will be saved as a file, and the URL of that file in the object storage data. It's the HDFS, right? The distributed file system, where we can
Mhm.
it will return the path of the data where it is saved, and it will be put in our metadata database, where we can refer it to directly.
All right. So the table that uh, you had, apart from that user data,
Mhm.
so content data table that would store the path to this
Yes,
file.
yes, paths to
But
this
that
file.
was not given there. Okay.
Yeah, yeah. It should, yeah. It is a must, because if we segregate the static content, because the data is probably that's
Yes, fine. That I got
yeah.
that.
Okay,
So you are storing it in the object storage, and you have metadata
yeah,
for those things.
right.
How would you
Uh,
generate the URL, unique
yeah,
URLs?
that's another piece of the puzzle that we have to solve, where again it
How
might
is
turn
that?
out. So I mean, in the read request, sorry, in the
Hmm.
write request, because there are two for the URL, there are two important jobs, right? First is when URL has to be generated by app server. Whenever this, I think
Hmm.
we need a separate box here, separate system that
Why do we need a separate system?
that will probably generate these URLs, because we can offload. I'm not sure. Because see, we'll have to unless the customer, unless the client has specified a custom alias, uh,
Hmm.
we'll have to I think if we have a separate system of generating URLs, like unique
Hmm.
keys, that will probably
Hmm.
offload our app server and will make our writes faster, because app server will only have to then distribute traffic to database and also generate a URL and just coordinate between those two.
Okay,
Uh,
but that could also be a bottleneck, right?
mm, well, in term when so when we're putting it into a database and uploading it, why would I mean this system will only generate because we don't care about what the short URL or what is the key, or what is the URL that's generated. We are just interested in a sort of a unique hash that this system will generate, right? So what this system is, it doesn't
The
care about.
system could be a bottleneck. Like, what if the system fails completely?
Well, then maybe that's what I was getting at. Maybe app server will already have some of the keys. Let's just say that this is like a hash generator. Uh,
Okay.
and it will keep those hashes generated. And let's say if this goes down, an app server will probably uh, app server itself can cache some of the hashes.
What
And
if uh, the hashes that have been cached in app server that have already been used, and it uh, hits this hash generator, but it has already failed. So in that case, don't you think the Pastebin service that we are designing, that would be a failure?
no, I think
That would fail at that point of time.
it would. So I think in that case we'll have to, this hash generator has to have its own database also, I think, which of own, the hashes that it generates. It needs to have its own
Okay.
separate component of hash, keys that it generates, so that even if hash generator goes down, it will have those, like, and a hash generator is responsible to mark a particular key being used, like has already been used, or it is unused, like it should manage those two database tables.
So hash generator itself is a server.
I think so, yeah. I wasn't thinking of it earlier, but I think it's going to be like one of the service itself, just like a URL shortener.
Yes.
I think, yeah, this is going to need its own
Fine.
database.
But in that
Yeah.
case too, I mean, a hash generator still is a bottleneck.
So how, like what scenario are you thinking this will be important?
Uh, See, as you mentioned, App Server having some cache in it, but what if that cache, I mean, all the hash that has been generated and stored in that cache that has already been used, and there is nothing left in that cache. Now, App Server hits hash generator, but it is already down. So there is no way that the database could respond to the App Server giving it or generating the hash.
Right.
Correct.
Yeah, I think we'll
So
have.
this
Mhm.
is a bottleneck at that point of time, because
Mm,
everything is being returned from hash generator.
But then we can make it we can introduce redundancy, right, in the hash generator. Like we can have multiple instances of hash, like a
Yes.
primary, secondary. Like
Yes.
one, if primary goes down, secondary will take over.
Yes. So it's more like standby hash generator.
Yeah.
Okay, fine.
Yeah.
Yeah, you
And
can
hash
proceed.
generator. Okay. This is the database. I mean, we'll have to worry about what now this database again. I think let me just segregate it into like a metadata and
So one more thing,
Mhm.
how many do you think hash generator? How would it create the unique URLs? That is something we did not go through, right?
Yeah.
We know that it would do it, but how would it do? How would it do it? How would it generate unique URLs? There should be some
Uh,
logic, some
yeah.
details to it.
Right. I mean, uh, what the hash generation could be, uh, unlike URL, because unlike URL shortener or time, those kind of systems, we do not have a URL to that we can use to encode or generate any hash. So I think what we are interested in is, so I mean, this hash generator just has to generate, you know, some we can decide like. Should it be 6 digit or 8 digit, as in a 6 character or 8 character or whatever the length of the string is? It should generate just those strings, and we can assign each of those to whatever is. What I'm saying
Which
is it's
strings
not
are we
dependent on the
considering here?
content. Sorry.
Which strings are we considering here? The content strings or something else?
No. That's what I think. It is irrelevant, or it's completely independent of the content that's being put into the paste bin. Whatever is the content,
All
hash
right.
generator only generates the keys offline. It just keeps generating those, and we can assign one of those to whatever is the data.
Mm, all right. So, which hashing would you use to generate those things?
Right. I mean, I don't know much about base 64. Encoding is something that I have seen, systems use,
Why base 64?
because we get 64. What, let's say we have six, we decide on 6 characters, we get 60, we get 64 is to 6 combinations, or different combinations of characters that the that this generator can
Okay,
use.
even if we get 64 raised to 6 power of
Mhm.
uniquely generated
Yeah.
strings,
Mhm.
so how much do we exactly need then?
For
Would we
our
consume all
need,
of them?
no, I don't. I mean, we'll have to choose according to what our requirement here is. We need. So how many requests do we have 30 million requests per month, uh, and 30 million into, uh, so, and 64 is to 6 itself is into trillions. So I think that should be enough, because the 30 million requests
What is the
into
total number of pastes that we do in the stipulated timeline?
in 5 years, you're saying, right? Or
Yes,
yeah,
that
so that
that
is,
should give us the
yeah, that's,
required number of unique URLs, correct?
yeah, that's what. So 30 million
Yes.
requests that we receive into 5, not into 5. This is per month into 60 months, right? So this will give
Yes.
us, 180 into 10 raised to 6. So that's like 180 into
1.8 billions.
10 raised to 6. Yeah. So I think the 64, like 6 digit or 6 character string should be enough for base 64 encoding. Like that should be
Yes,
more than
fine.
enough for us. Yeah.
Yes, 64 raised to 6 gives us approximately 68.7 uh, billion, not
Okay.
trillion.
Okay, but that should still be okay. Or maybe safe side, we can go with like 8 or 9 digit. I don't know if there's a base 64 like encoding
Um,
or
Even if,
9.
I mean, the number of unique URLs that we require is 1.8 billion. So, and that we are generating here is 64 is to 6, which is
Yeah,
68.7 billion. So, don't
yeah,
you think that is too much? Anyways, that will do this. So,
yeah. But yeah, yeah. I mean, it will probably be a lot. Yeah,
all right. So, how would you then? Now, what we have done is we have generated unique URLs,
yeah,
and we know how write happens.
right.
Uh, what if somebody tries to read something that is not
Yeah.
there, or that has already expired? What happens then?
Uh, so if yeah, that's a good question. Now if the client uh, yeah tries to access from the app server, and there is if the entry doesn't exist, we will return and maybe HTTP
How would you check
404.
the entry does not exist?
uh, for that I think we'll have to partition a database based on some parameters, so that the retrieval of the database or retrieval of the data is fast. Like first yeah, because we'll whatever the
So we'll
URL.
do partition for retrieval of data to make it fast, or something else.
See the
What do we need
fetching.
partition for?
No, we need to partition the database so that the database storage database servers have they are evenly distributed their load, so that not only
Hmm.
only one database is not server is not running too much of a data. So I think to evenly distribute it, we will introduce partitioning, but it will also help us fetching data faster, because we can we have, let's say, a URL that we have received for the read request, and if we partition it based on some hashing function, then so that uniquely identifies. No, but it won't be based on, sorry. uh,
So how
it's
would you partition it then?
I think the
How would you
partitioning has,
partition it?
yeah, what is the data that we have is user ID. We can do it based on you, no, but user ID is not a.
User
I think
IDs, then there
we'll
could be
have to,
multiple user IDs. So,
right. I think we'll have to do it based on URL then. The URL that this hash generator has given us. So
mhm.
I think we'll have to partition a database based on a URL, and so that
Is
whenever
there
the
any
read
other
request,
way?
uh, there are not many fields in a database though.
Okay, no
I mean,
issues.
for
So
based
we'll be
based on text.
partitioning it based on URL hashing, right?
Yeah, yeah, yeah,
All right. Um, Fine. So assuming we have already partitioned it based on hashing
yeah.
our URL,
Hmm.
and then we have to retrieve one of the URLs. So how would you check it, and which database would you go to check that for?
Database has to be this main database or object storage that I said. It has to, because that's our main storage, the object storage and our object content. So first the hash generator will give a, so we already have the URL from client, and we have to, since we've partitioned a database based on URL, or we generate a hash of this URL, and based on that we know what database server to go to, and fetch the data from there, and serve it back to the client. That's how we can do it, I think.
Okay.
And that will be like a uniformly random distribution, where, because we are doing it based on hashing here.
All right. So read is done, write is done,
Yeah,
URL generation is done. Now, what else
right.
is remaining?
Custom alias, but that's again a configurable parameter. I should briefly mention about, I think we should discuss about the consistent hashing part of it, where, or even, even
We did
before
not
that,
discuss about expiration, right?
yes, yes.
How would we use this expiration? How would we do that?
So whenever, like when this was generated, okay, so when the URL was generated, like a short URL for this particular Pastebin, we can put a timestamp in the database, so that's fine. But whenever there is a read request for this content, and we fetch from the database, we see and we can see what the timestamp was, like when it was put in, and we know the current timestamp. We
But
can
we are
just say
not storing creation timestamp, right?
we will, right? Why not? I think I did
I
hear it.
don't know why not. You said
Oh, okay.
they will be storing the expiry date at maybe whenever that
Yeah,
date comes, we will
right.
be simply deleting it or something.
Hmm. Yeah, I think we need a creation time. Uh, we need. I think I meant, I meant it that way. I think I don't think, because expiry, even if we say, let's say, we created today, that is 30th of October, and we after, and we put an expiry date after whatever, either custom or 5 years. That should also work, right? That should also work. Like if
Yes.
we at creation time, we
So
can put
there's
an expiry
just
date.
it's just a difference of
Yeah,
logic, nothing else.
right.
So it's
Yeah,
fine.
doing it. Yeah, it's a difference of doing it now, like at the creation time or at fetch time.
Hmm.
So yeah, I think that should also work. Like we can see the current timestamp, and if the expiry has already passed, we will go ahead and remove database entry from the database, and respond back with 404.
Hmm.
And we can
Okay.
also have a system that silently monitors all the expired keys or expired entries in the database, and that's like a nightly job or something, or maybe a weekly job. That'll remove all the expired entries from the database, so that we are saving on some storage.
If we are assuming that we are creating this system for whole world, so in that case, we won't have this opportunity to run that scheduler
Oh,
on a weekend or during night. So that won't work, I think. Anyways,
yeah. But we can
um,
have a periodic thing, right? Like maybe some time, like 7 days or whatever is the
we can do that.
yeah. But it has to be
That
or
would
maybe
be
we can have,
additional load to the server.
yeah, okay. I
Fine.
mean, that's just an optional sort of an optimization, but yeah.
Uh, okay, so
We also, to make it faster, we also can cache some of the content on app server, or we can introduce, yeah.
what would be? I mean, how would you cache it then?
Like this app server would, let's say some of the URLs are very popular, so we can save them into an app server. App server can have its own cache, or or again we can introduce another component of cache server, another cache servers, and that they will basically, we will check in the cache first if the data is there or not, because retrieval from memory is faster than retrieval from database. So uh, that will
Okay.
include another hop, uh, adding into database. Like while adding into the database, we should first check if we already have it in the cache or not. But that will optimize the
Yes, we
system
can do
also.
that. All right, so write is done, read is done, URL generation is done,
Yeah,
and expiration is done, caching is done.
yeah,
You have already mentioned where we will be using load balancer.
yeah.
So I think uh, the system design of Pastebin is done. I mean, we can mark it as done. So
Okay.
how do you think, I mean, which are the areas that you'd like, I mean, you can improve on?
Uh, I think caching is a whole lot of
Not on
areas.
the system design part. I'm talking
Oh, okay.
about
Ah,
we have like finished this interview. So
okay, okay.
uh, post
Okay.
this.
So if you guys finished, then I think So, Satyam, are you done asking?
Yes, I was asking his feedback on the interview experience.
Okay. So,
I also have something to share for him, and I'll point it out.
yeah, so
But
let's do in
first,
this way so he can share something about him, followed by
Mhm.
uh, feedback from the audience, and then you can wrap up. Would that work for you?
Yes, fine.
Okay, awesome. Thank you, Satyam. Thank you, Kaustubh, that doing this thing. So with this, Kaustubh, do you have anything you want to share? You think you can change, improve, or done different?
I mean, I've always struggled in the traffic estimation part. I was so that was an area where so I wasn't sure if I was trying to dodge it. I thought, but it's always it's a tricky part for me, and so that's where I struggled the most, I think. And because what I've seen, I've done one or two interviews, and what happens is that because I end up spending so much time in traffic estimation, I end up that just eats up time from my system design because I
Most of your time in traffic estimation goes or gets eaten up because of the
right,
calculation.
right, right, exactly.
You have made the
So
calculations complex rather than
yeah,
easing them.
correct.
Okay.
So,
So yeah,
Always get the round figure and just estimate it, approx it, and in the interest of time, just simplify it. The
And don't
estimate.
use the round figure like 1 month equals 2.5 million seconds. That is too much to divide and then calculate and all. It's fine that you
mm,
have remembered it, but we
yeah,
can always do it like in, I mean, as we are breaking it down to queries per second, so we can go it down, make it down to 1 day and then 1 second.
mm,
That could
yeah.
be easy, but anyway.
That's a good. I think the assumptions have to somehow have to change those, I think.
so one tip here is I generally use this Microsoft OneNote for capturing requirements and calculation. So there you can get a inbuilt calculator. If you write 2 into 4 equal to, it gives
Yeah.
you the result. And then let's say you do 1000 into 5, it will give you something. Then in the
Mm.
next calculation, simplify if it is like a very complex number, like 8231 something, just say like, okay, let me assume it's like 800K or whatever. So doing calculation in OneNote I found is a bit easy. It is an inbuilt calculator. You write, it will give you a result.
Okay.
I hope interviewers would allow us to use OneNote.
So you are sharing your screen. So doesn't
Mhm.
matter where you write, where you draw.
Then this is a really great suggestion. Thank you.
Yeah.
So these days they give full flexibility. You want to
Yeah.
you want to put on your camera, do it on a whiteboard, they are fine. Want to share your screen, they are fine. Want to do something like Excalibur draw where you don't share your screen and both people see on their side, that's also fine. So basically they are there to help you in the way how you are comfortable.
Okay.
So Kaustubh, anything else you want to share?
Uh, Except for that, I think the rest everything was okayish. I think. I can't think of anything else.
When you were talking about, I mean, when we were
Mm-hmm.
discussing about HLD, you went directly into complete design,
Yeah.
detailed design. That is one more
I mean,
thing.
again, that's one of the things I was confused about because I couldn't manage. The reason I went directly there was because I couldn't manage the time in one of my earlier interviews. Uh, I spent, I wanted to go this way, like do a high level design and then go ahead and draw the detailed diagram. But then there was hardly any time left for me, and then we ended up discussing so much about high level design, or only the block diagrams. I couldn't speak. I couldn't explain so many other things that I wanted to talk about. So
For this, I think what we can do is uh, we can spend less time in the estimation part and some time in the high level design, and then move on to the
Yeah.
component designs.
Right.
That is something that was spoken in SD skills previous videos also that I've seen.
Okay. Yeah. Yeah. I think that, this the traffic estimation part is the bottleneck in my.
Because we are discussing or we are designing a system, not only estimating it. So the basic problem here, or the primary goal here, is to design the system.
That's right.
So, Kaustubh, my tip would be to set max 5 minutes on timer or something, so you don't go beyond that for estimations. And then you can say to the interviewer that in the interest of time, I will go to the next section and we'll come back to estimations if we want to fine grain it.
Right. Okay. That
But
can be done.
but still take interviewer consent. So and
Definitely.
yeah, so if you take the decision that can go against you, like you say, okay, I'm moving ahead, and interviewer is still thinking like we should spend more time. So basically, it should be a recommendation plus confirmation.
Yeah, I second
And
that.
You should
Yeah.
to a logical end. At the same time, just say that I will just ask the interviewer that I will come back to it if it needs more clarification on details. Or you can also ask that if you want me to focus a little bit more on estimations, I can do, or I can come back to it later after we finish the design and all the other low-level design and database and security or any other things.
and
Yes, that would be good.
Can we now give feedback, the audience?
yeah,
for both
yeah.
the
So
yeah, so I'll just do a quick feedback. The interviewer, the candidate, I mean, he already spoke about the time management issue and others told, so I don't want to speak more about that. But the candidate did start strongly in the sense he talked about maintainability and scalability in the requirement. So that was good. And the interviewer I felt was very good. I mean, not just in system design, I'm talking in general, like the way he talks, it was quite mature. And if I get interviewers like this, it would be very nice, because then I'm very, because he didn't stress out the candidate, he was calm. So he puts the candidate at ease. So that was very good of the interviewer. I don't know what his age is, but he sounded very mature. That's about it from my side. Thank you.
Thank you.
awesome. Anybody else? Anyone else wants to give a feedback?
I can.
Yeah, go ahead, Raghu.
Yeah, so the interview was very good. I think the conversation was very, very informative. I really kind of learned quite a bit from the whole conversation. Also, something that I like, the kind of questions which are being asked and the way they were handled were actually pretty good. One observation, and I believe it's kind of already been answered, like given as a feedback, was I felt there were some interruptions, as in the line of thought. If I were the interviewer, I would probably consider there were some interruptions in my line of thought, because some of the questions were kind of slightly, and that could have probably contributed to spending more time on the high level rather than getting to the low level. So what I could probably suggest is, as you said, like parking some of these questions if they are kind of digressing. Maybe we could ask the interviewee can ask, like, can you park this and then come back, because I don't want to break my chain of thought and stuff. So other than that, I think it was a great conversation, and I learned quite a bit. Thank you.
Thank you.
Great finish. Good to go. Sorry.
So in this case, what happened was in HLD and the detailed design, when he was going into that, So that was when I think this could have happened that you suggested. Uh, because it was confusing. Like we were discussing the HLD, and Kaustubh was going in detailed design. So there, and also to wrap things up, I mean, we mixed it.
That is true. That was my observation too. That we kind of crossed that boundary from high level design to the low level design, and then kind of coming back. So
Because if one has not designed, I mean, the high level design is not already designed. So just going through the replicas and making more servers, that confuses, right? So it's always better to, if you have to skip the estimation part completely, do it. But it's always better to uh, design the HLD and then move towards the component designs.
Okay, cool. Anybody else who wants to give the feedback? Okay, if no one else, then I will give it to Satyam to wrap up the feedback then.
Yes, first of all, Chavi asked some question about replica
No,
as is more
this is,
instances for.
do you have any feedback for Kaustubh?
Okay, for Kaustubh, it is the same thing, the estimation part and the numbers. Of course, you can ease things up with the numbers. The next thing is go with the flow. Like if we are discussing the HLD and we are focusing on HLD, then let it be only HLD, and then move towards the other part. Uh, these are the two things, and
Anything
mm,
you liked?
yes, I liked the first part that was already mentioned, like how he came up with the requirements. Because whenever I practice system design, I do the same thing. Uh, Most of the times, I get confused with the numbers too. That is my issue also, and that is why I wanted to see how he performs and what happens. I mean, is it something that happens with everybody? So I asked him to pick up the numbers. Those maintainability and scalability. Maintainability, I have never come across that, so I didn't even know that word when he mentioned it. Uh, Rest everything. I mean, whatever questions were asked to him, he was eventually he came up with an answer to it, and with a correct and expected answer, I can say. So that is the positive. uh, I would suggest Kaustubh to keep practicing it, keep practicing the system design concepts. Uh, Even if you are reading it, then think that you are the interviewee and you yourself are the interviewer, and uh, then practice it like that, like a mock interview. So that would help with time constants and everything else.
Okay. Thank you. Thank you,
That's
sir.
all.
Awesome. This was great. Kaustubh, any questions, clarifications you have?
No, I think I'm good, Asim. And
Okay,
that was
so
a great feedback from Satyam and everyone else. So thank you for your time and thank you for your feedback.
yeah, and I also put one link in the chat if you want to see. There's no particular format, but there are some tips if you want to follow. Okay, so
Yes.
I think with this, we are good with the interview and the feedback. I will stop the recording now, but we can chat around the design and other discussions followed by this.